Hey everybody and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy where we are learning networks together. And on this video what I'm going to be going through are three different topics, areas or protocols as such, and of course how to configure them and do a few show commands to verify that they're actually working. Now the first topic, area or protocol we're going to go into is something called LLDP or Link Layer Discovery Protocol. Now for the Cisco guys out there, you will know this as CDP or Cisco Discovery Protocol, but that's a proprietary protocol from Cisco. LLDP is an open standard for actually discovering connected network devices connected to another network device. It's Link Layer Discovery Protocol. And attached to this is really an extension called LLDP-MED or Link Layer Discovery Protocol Media Endpoint Discovery, which is about discovering the capabilities and the identity of connected endpoint devices connected to a network device. So that might be a VoIP phone, it might be a camera, it might be an access point. And that's where we're going to start is LLDP and LLDP-MED. And that's important because this then leads on to the second part when a device has been discovered, which is PoE or Power over Ethernet, which is not a new topic. It's been around for quite a few years now. It is where you've got a powered supply equipment such as an EX switch, and that is providing power to those connected devices, those VoIP phones, cameras, access points. And we'll go through how to configure PoE on an EX switch and verify that. And finally, what if that connected device that's been discovered via LLDP-MED and has been given a certain amount of power through PoE or PoE plus or PoE plus, what if that is a VoIP phone where it's connecting to that same access port on that EX switch and it has essentially two streams of traffic, one for voice for that VoIP phone and one to a data terminal where typically a user's laptop or workstation would be connected to that VoIP phone and thus to that EX switch. So we're going to go through how to configure that same access interface on an EX switch to accept two different streams of traffic, one for the voice VLAN and one for the untagged data traffic. How to set that up, how to verify it. So it sounds like we're going to go through a lot, but I promise you it is so easy and so simple to do on Juniper devices. But what we'll do is we'll break this down. We'll go into LLDP and LLDP-MED first, a little bit of theory, configuration, and then we'll do the same for PoE and then the voice VLAN as well. So stay tuned. I promise you this is going to be a very easy video. Okay, so let's start off with going through very quickly what is LLDP. Well, as I've already said, it is standing for Link Layer Discovery or Discover Protocol. Really, the answer is in the question, what is Link Layer Discovery Protocol? It's a protocol designed to discover connected devices, network devices that are connected to one another. Now the important point here is that this is vendor neutral. Yes, Cisco have their CDP protocol. I have no idea how different that is to LLDP, but essentially they're really doing the same thing. It's allowing network devices to discover the capabilities and the identity and quite a few different details. We'll come on to that in just a minute, of those connected devices that are on the opposite side of that connection on that interface. And if you want to know what the IEEE standard is for it, if you want to give it a read, please feel free. I'm absolutely not going to do that, but it's IEEE 802.1ab. It works on both layers 2 and layer 3. So if you know the TCP IP suite, that is why it's called Link Layer. And also it does actually work on both access and on trunked interfaces. All this stuff you can read. But when we've got a switch here and another switch here and another switch here, these are sending the LLDP PDUs, the protocol data units. It's a bit of a long acronym that. I'm not going to keep saying that. But these are sending those link layer discovery protocol PDUs back and forth to one another. When that link initially comes up and it gets up, it sends LLDPs automatically by default to connected devices. Now please note that this is if the devices have passed the authentication. So if you're using something like 802.1x and it fails, then LLDP frames, PDUs, are not going to be exchanged. But if a connected device passes that authentication, passes something like 802.1x, then LLDP frames, those PDUs, are going to start being exchanged. And what we actually have here is, in each of these switches, is that they have a database. Just like every switch routing device has a table, it has a database of entries. There's an LLDP table, there's an LLDP database, which stores the information of all these connected devices that they've heard the PDUs to and from, and it stores the information of who they are, what's their chassis version, and all the details that they actually get from something called the TLVs, or the type length values. And that's important because that's actually the next part. So as I just said, LLDP, those frames, use TLVs, or type length value, tuples. Don't worry about the tuple part. But what the LLDP basically does is we've got the Ethernet frame right here. And inside the payload, so right here would be the payload, would be the LLDP, the Link Layer Discovery Protocol Data Unit, or PDU. And this is made up of mandatory, or MTLVs, where it defines what is the type, what is the length, and what is the actual value that's inside that particular header. And you can actually see that there's quite a few mandatory TLVs that have to be in there in an LLDP PDU. So a note here, you've got the multicast MAC address, the layer 2 MAC address for LLDP. So when a device like a switch receives a multicast MAC address and it sees it's 0180C2000000E, it knows that it's an LLDP frame. But coming back to that PDU, you can see right at the beginning is this chassis ID. And if you look on the right hand side here, you can see that the chassis ID, that TLV, actually identifies what is the MAC address of that connected network device. And then you've also got a mandatory port ID. This identifies the port from which that LLDP is transmitted. So just in two headers of that PDU there, if a switch receives a PDU, it will know instantly who's connected to me, what is the MAC address of this switch router, this firewall device that's connected to me, and what is the port ID that it's actually using to communicate to me. And it stores that information in its database, and it basically just builds as such a topology tree of who's connected to who. And an important one here is this also time to live, or TTL. Now this is not the same as the IP protocol header TTL. What this actually defines is how long that this, and here's the information right here, it actually defines how long that this PDU should be trusted, how long it should be stored in that device's LLDP database. I think about the default is, I think it's about 120 seconds or so, but obviously after a certain period of time, it's no longer trusted, and hence this TTL for this time to live value is basically defining to a connected device, here I am, here's my MAC address, here's my port ID connected to you, and you should only trust what I'm giving you for this period of time. Once it expires, you should delete this information from your database, but hopefully I'll update you before that actually happens. And you can see there's a lot more information here. I'm not going to go through it all. Mandatory information that will be there for every LLDP protocol data unit, all in this payload here of that Ethernet frame. But there's also optional TLVs. Optional being it may be there or it may not be there. What those optional attributes are, I honestly don't know. I would imagine that every vendor can define their own optional TLVs as part of that PDU, but it's optional. It might not be there. And here's an important point. An LLDP will update every 30 seconds by default. So every 30 seconds, it will send, a switch will send to another connected device, a network device, an LLDP update every 30 seconds, or when there's a particular change. So if an interface doesn't go down, but say you change the port from port 1 to port 2 connected to that same device, so you change over the ports, that's going to be a change in the network setup as such, and that's going to require an LLDP PDU to be sent. So it's 30 seconds by default, or when there's a local change. And this is different to that TTL in that PDU up here, because that's defining you should trust what I'm giving you for 2 minutes or 120 seconds, I think, by default. But typically by default, the LLDP is updated every 30 seconds anyway. So really this TTL should never really expire. And as I said, these are sent unsecured. So you do need a mechanism like 802.1x to authenticate these connected network devices before they get access to the network. LLDP is sent unsecured. There's no handshake mechanism. There's no encryption. There's no hashing. It's completely sent natively naked on the wire. So I highly recommend you have some authentication mechanism in place like 802.1x, which I'm going to do in a later video, to authenticate users before you start exchanging the information of your connected network devices to this potentially rogue network device. And this is what LLDP-MED is. It's this link layer discovery protocol, but for media endpoints. So when we talk about media endpoints, we're talking about these VoIP phones, or maybe some kind of IoT cameras, or we've all seen these when you go into any store. You've got the cache points, these kind of wired or maybe even wireless tills. We've also got from Juniper the Juniper-MED access points. There's always full disclosure, I work at Juniper Networks. So really the idea around the LLDP-MED, and the MED part is an extension to the IEEE standard, is it's just enhancing that discovery between that switch, between that firewall and these endpoint devices, which is not a network device, it's an endpoint. It's discovering who they are, what are they capable of, etc, etc, etc. And just like LLDP, LLDP-MED uses TLV messages to facilitate that deployment of the device, and it really brings into it some new TLVs. So you've got one here, the network policy. So what you can do using LLDP-MED is the switch can advertise to something like a VoIP phone what is the VLAN that you should associate that VoIP traffic to, just for example. So it's speeding up the deployment. You can also advertise in another TLV what is the location of this VoIP phone, of this camera, of maybe this access point, or of this till, and even use LLDP-MED. And for me, this is the most important one. What is the power requirement of this connected device? And that's why I'm going to do PoE in the next subject, in the next part, power over Ethernet, because each one of these devices, maybe not the till, but the access point, the camera, the phone, they, of course, just like any device needs power, but those devices are typically going to use PoE, PoE+, PoE++, potentially. And we can use LLDP-MED to advertise not only what is the VLAN you should actually go into and dynamically associate that traffic to that VLAN and define the location of these devices, but actually use LLDP-MED to define what is the power requirement. What power am I actually going to give this endpoint device? And the endpoint device can actually advertise back what is my power requirement as well, so that the PSE, that switch that has power over Ethernet capable features to supply the right amount of power to that connected device. And LLDP-MED, it actually uses classifications to understand when a connected device connects to my network, hopefully authenticates correctly, successfully, what is this device actually capable of? So is it a class 1, is it a class 2, class 3, or is it a class 4? You can see the different types of classes here. Honestly, I don't know if there's more than class 4. Potentially there is at the time of me doing this video. But we've got the generic LLDP-MED, which is for IP communications controllers. Not too sure what that is, but presumably some kind of VoIP controller. Then we've got media streams, then we've got IP telephones and soft phones. No idea what a soft phone device actually is. And then there's class 4 network connectivity to devices such as switches. So LLDP-MED does a lot. It's an extension to LLDP, but it's discovering the connected endpoint devices, defining what is their class, maybe dynamically assigning that device into a particular VLAN. You can even associate that into a particular forwarding class if you're looking to do something like class of service for preferential treatment of voice traffic over data traffic. That's for a later video. And even define what power should I be given to this connected device. And all of this so easy to set up on the Juniper devices. So here we go. Here is the lab for this video. Very simple network, hence I'm doing lab. So there's a user, VoIP phone, VEX switch. Now, full disclosure here, I'm an honest guy. This VoIP phone is not actually a VoIP phone, it's actually a VEX switch. I've just changed the image, changed the logo. I can't actually find a VoIP phone to import into EVE-NG. So I know I'm cheating a little bit here, but really the configuration, everything we're going to be doing is on the actual VEX switch anyway. So let's log on to the VEX switch and let's go into edit protocols. That is where you will configure LLDP and LLDP-MED. Now, really LLDP-MED, because it's an extension on LLDP, everything you configure in LLDP is going to copy over into LLDP-MED. It basically inherits a lot of its configuration. So LLDP-MED inherits a lot of its configuration from LLDP because it's an extension to that standard. But if I just do a set LLDP, well, actually, let me just do a quick show just to show you there's nothing really configured. So if I do set LLDP, spell it right and hit question mark, you can see there's actually a lot that we can configure. Now, I don't want to go through everything, but just to show you the ones that I actually find really interesting. First one right at the top here is this advertisement interval. Do you recall that I said at the beginning that the PDU for LLDPs are sent out every 30 seconds by default? This is where you change that interval. So you could define it to be a minimum of 5 seconds or a maximum of 32,768, whatever that is in hours. That's how you can adjust the interval and when and how frequent those LLDP PDUs are sent out. The other one I want to actually define for you is this hold multiplier here. What this basically does, as the name implies, is it multiplies that advertisement interval of default 30 seconds and it then defines from that equation the TTL. So if this was actually defined, the hold multiplier was defined to be 4 as a multiplier, it will then do 4 times 30 seconds, which is defined by default in the adjustment interval, which then equals 100, of course, 120 seconds, which means the TTL would be 120 seconds. That's how you can adjust how long those entries that have been received from LLDP messages should be stored in the LLDP database. And the other one I find really interesting as well is the TLV filter. So you have mandatory, LLDP has mandatory attributes that has to be advertised in the PDU, but there's optional ones. You can filter them out and you can even select what ones you want to transmit to a receiving device. So I find that actually very interesting, pretty cool to be honest. But in terms of the configuration, it's very easy. All you have to do is do set LLDP interface, hit question mark, and you can basically say I want to advertise out of all interfaces. I don't really like that, so I'm going to do set GIGI 001 because that's where the VoIP phone is connecting to. And I'll also do set LLDP. I keep doing LDD for some reason, but let me do the adjustment interval. No adjustment, the advertisement interval, and let's change that to be 40 seconds. And I will now do the LLDP hold multiplier of 4 times. So that's 4 times 40 seconds. That's going to give 160 seconds or 2 minutes and 40 seconds if I do quick maths there. And let's do set LLDP TLV filter and hit question mark. I'm not going to do this, but notice here's all the optional, I believe, optional TLVs that we can filter out of. We could just say, no, we don't want to actually receive this advertisement. But if I just do a quick show, that's it. I've very quickly configured LLDP. To configure LLDP-MED, which is advertising capabilities to an endpoint and discovering endpoints capabilities, all you do is set LLDP-MED. We define the interface. I'm going to do Gigi 001 again. And if I just hit up and do question mark just to show you, there's not much you can actually do for LLDP-MED. And that's because it gets a lot of its configuration from LLDP. But we can do the TLV filter. We can define what optional TLVs we want to actually advertise, as well as this fast starts, which is a discovery count for MED. So yeah, and the interface, of course. But if I just do a show on this, you could see very basic, easy configuration, and let's commit this. And whilst that's actually committing, let's go on. You can see it just done that there, very quick. I'm going to go onto my missed instance to show you the various show commands to verify LLDP and LLDP-MED, purely because my lab here in my home office is more interesting than what you actually see here. So let's go on to my missed instance. So this is my missed instance, David Townsend. Here is my EX2300 compact 12-port switch, literally sat right to the next of me. And I'm just going to go in utilities, remote shell. And there might be a bit of a lag to this because, you know, my bandwidth at home isn't the best, to be honest. But some very easy show LLDP commands you could do is first just do LLDP local information. What this means is, what am I advertising to other network devices? What is this EX2300 switch going to advertise to whoever's connected to it? So you can see here's the local information. You can see this is this 2300, this switch's MAC address from Juniper Networks. Of course, it's this particular switch model running this version. This is when it was built. It can do bridge and routing capabilities. Here are all the interfaces, their state, up, up, down, down, up, up, down. I've got Gigi 000, which goes to my bare metal server where I'm running Eve and G. I've got an uplink to my SRX for WAN connectivity. Gigi 004 I think goes to my Xbox, and Gigi 005 actually goes to a missed access point that is right above my head. And that's where LLDP-MED comes into it. You know, you don't actually do show LLDP-MED, you just do show LLDP. And what I can also do is define the neighbors, hit question mark, and you can say what interface, and I want to do this at the Gigi 005 interface, which goes to my missed access point, I believe. And if I hit question mark, there's no detail here because it's going to give detailed information anyway. But let me just hit all of this and let's scroll back up. So yep, you can see this is the top here. So you could see it's using its Gigi 005 interface on the EX switch. This is the AP's MAC address. This is the port ID and its MAC address, so Ethernet 0, and it has this MAC address. This is the system's name. It's a MIS systems 82.11ac access point that goes up to Wi-Fi 5. This is its IP address and all this other information you get here. So pretty cool information. What are some other commands you can do? Well, let's do show LLDP. Let's hit question mark. If I do show LLDP detail, is there anything after this? No. This is going to give quite a detailed response. So now here's all this switches configuration basically. So all the interfaces, the VLANs, their names. I've got two neighbors. LLDP is enabled. LLDP-MED is enabled out of all interfaces. You can see the LLDP. It's advertising every 30 seconds. By default, transmit delay 2 seconds. Hold timer is 120 seconds. So I would assume then that the hold multiplier is 4 times 30 seconds is 120 seconds. And we've got LLDP-MED enabled and it's doing a fast start count of 3 packets. So there we go. That is how you can quickly and easily set up LLDP and LLDP-MED, and how you can use quite a few different shell commands to really go through the database on, in this case, an EX2300 switch. So let's now move on to PoE, or Power over Ethernet. Obviously, there's very smart people out there who will be able to go into a lot of detail into how this actually works. I'm most definitely not one of those people. I'm just being honest. But from a very high level perspective, what there is there's a PSE, there's a power supply equipment, and then you have PDs, which is the powered devices. So that would be things like your VoIP phone, or maybe some kind of camera. I'm not too sure what the video is there, the video icon is meant to be showing, or maybe some kind of wireless access point or cache point if you're talking about particular retails. Anything that is getting its power over Ethernet would be a powered device. And there are different standards for PoE. So initially there was PoE, or 82.3 AF. Now that supplied up to 15 watts or 15.4 watts, as you can see, of power. But then, as we do in general modern society, we want more power, we want more applications, we want more bandwidth, and that means that the power devices that are giving us that connectivity, they needed more power. So then PoE Plus came about, and that supplies up to 30 watts from one physical port on that switch to those power devices. But then again, we wanted more bandwidth, more hungry bandwidth applications, which means those power devices needed more power. And then PoE++ came about, and that supplies up to 90 watts of power on a physical interface. From a high level, that's really what PoE is it's providing power over that physical cable, over that Cat5, Cat5e, etc, etc. Honestly, I don't know if it can be done over fiber optics. I honestly don't know on that one. I have to look into it. But that, in a nutshell, is what PoE actually is. But when you talk about PoE, you have to take into account something called a power budget. Now, a power budget is, as the name implies, it's a budget of power, just like you have a budget of money every month to spend on bills and maybe a mortgage and spending money and saving money. You have a particular budget. You have a certain amount of power coming in from the switches, and that might be 320 watts, as you can see here. So why then is the power budget for PoE only 130 watts? That's because the switch, regardless of vendor, needs power for everything else. It's not just for PoE. Hence you see a power budget here of 130 watts, and then that is distributed, shared across all of its capable ports that support PoE, PoE+, PoE maybe plus. But one thing you have to take into account is that the power budget, it does depend on these two things, the switch model and also that PSU, that power supply unit. Let me write that here actually, that power supply unit that comes with the switch. So that's really what's been shown here. So you've got an EX switch with one 320 watt PSU, and it had a power budget to share to all ports, PoE ports of 130 watts. But then here you've got an EX switch with 600 watt PSU, and you can see the power budget is considerably higher. Now when you've then got that power budget, you then have something called a PoE controller. The PoE controller is controlling the power, it's distributing the power, it's distributing that power to the ports that are requesting it, which is really coming from those media endpoints which have been discovered via LLDP-MED. That's why I've done it first. But what I find really interesting when it comes to the juniper junos configuration is that there's actually two management modes. You've got static and then you've got class. Static being you manually configure in the CLI or maybe in the user interface, you define manually what is the maximum power that you want to give to a connected device. And then Junos, that switch, will give that maximum power to that connected device. Now the downfall of this is, say you configure the static to be 8 watts, just for example, that PoE controller is then always going to give 8 watts of power to that interface, even if that connected device only needs 6 watts. You're wasting 2 watts there. So what I think is more beneficial in terms of flexibility and not wasting power is this class managed mode, and that is really determined by that connected device. So the connected device, which has been discovered via LLDP-MED, tells the switch and the switch, the PoE controller understands this, you are a class 2 or class 3 device, and typically VoIP phones fall under a class 2 or class 3 device. You need 15.4 watts or maybe 7 watts. I'm going to dynamically give you this based on your class, and if that power fluctuates, if it varies, I'm going to vary that as well. So quite interesting. I personally don't like the idea of static, but I could see some use cases of this. But in terms of flexibility and not wasting power, I think the class managed mode is a little bit more beneficial. So here I am back on the lab, and let me go back into my VEX switch. Hit enter, and you can actually see I'm already in edit PoE. That's where we go to configure PoE, power over Ethernet. But if I do a quick show, you can see there's nothing there. Now point here, I'm going to be able to generate this configuration and even commit it, but I'm not going to be able to do any show commands because this is a virtual environment. Physically, these devices do not exist. There's no power to share, hence I'm using Mist as a backup to show you those show commands. But if I actually just do a set and hit question mark, here are some of the commands that you can actually use on Juniper devices for PoE. Now if I do set management and hit question mark, note here are those two management modes. So class based on the power allocation method, or static, being I'm always going to be giving you this power no matter what. So I'm going to do set management class and hit question mark, and I can then define what is the interface I want this static management, sorry, not static, this class management to be assigned to. If I hit question mark under here, we can then also say what is the priority of this. Now, it's actually GigE001, isn't it? Now, if I define this to be a priority of high and do a show on this, if I define the interface, it's not on the lab. If let me do GigE000 again and priority of low, hit question mark, what does this mean? What this means in English is that there's obviously this power budget is in there. This switch will have, if it actually existed physically, it will have a power budget. And let's say it's 120 watts. If there's a lot of power being consumed by GigE002 and GigE003, by having this priority value here, what this defines is it allows Junos, the PoE controller specifically, knowing its PoE budget, it can see that it's running out of power, and it will actually assign more power to this GigE001 interface because it has a high priority. This has a low priority. So the GigE000 interface is not going to be preferred. It's not going to be given as much importance because it's got a low priority value. It's not, if there's a starvation of power, then the PoE controller will give higher priority to interface GigE001. That's basically it. That's what's meant by this priority value. And you can even define things like notification control. What is the notification control? What you define is you define the FPC, the line card, and if you've configured SNMP, then you can get SNMP messages sent from this Junos device to an SNMP server. I'm not much of an SNMP man, but you can get SNMP messages sent from this switch to an SNMP server to define, hey, this is the PoE on this particular device, this is the budget, this is how much power is being consumed on each of these interfaces, etc, etc, etc. So what is this LLDP priority? I had to look this up, so let me drag it over. Let me read this out for you. It configures the switch to assign interfaces the power priority provided by the power devices by using LLDP power negotiation rather than the power priority configured on the switch interface. So, what does that mean in English? What that means in English is if you define a priority value for this particular interface, then the LLDP priority will override that. So if I do show, you can see I've defined LLDP priority. So if an TLV comes through that defines a priority for its PoE, and if that's on the GigE00 interface, which has a priority of low, if that TLV in that LLDP message says actually it's a high, then that's going to override whatever it's actually been configured in the Junos here. That is very quickly how to set up PoE on a Juniper device. Let me go back to my EX switch. Let me go back into my remote shell. Open this up a little bit more and let me do show PoE question mark. And now I can define, I want to see the general statistics, the information on the controller, the interface, and even telemetry. So you can configure telemetries to be sent to some kind of telemetry device. For some reason, it's not in the junos, probably because it's virtual. But do show PoE and let's look actually at the controller, and you can see the maximum power that can be sent. The power budget is 124 watts. What's currently being consumed is 10.8 watts. The guard band is 0. This has a class management, so that's dynamically assigning power to connected devices, and the LLDP priority is disabled. So I'm not going to get any LLDP messages that come through and say, yeah, I need a better priority than what you've actually configured. Let's do show PoE on a particular interface, and I'm going to do it out of the GIGI 005 interface. Can we do detail? We cannot, but now I can see this is the access point connected to my EX2300 switch. You can see it's connected to this interface. It's up, is on, and this is consuming 10.6 watts. It has 82.3 AT. That is PoE plus. I think PoE plus plus is 82.3 BT. But yeah, some very easy commands there. Another interesting command you can do is not actually show PoE. You could do show chassis hardware. And you can actually see this is my EX2300 switch, it's FPC, the number of interfaces, but here is that power supply unit. I think that's Juniper power supply unit, 170 watts AC. And if I actually do that show PoE controller, you can see it's got 124 watts. So that means out of 170 watts single PSU, 124 watts of that has been provided to that PoE controller. And that's then distributing that to all of the devices connected to me, to this switch that require PoE. I think that's really just this missed access point. So here we are, here's the last part of this video where we're going to go into voice VLAN. What is a voice VLAN? This is where we have got a physical interface like GIGI 006 on a switch, and it is receiving both untagged and tagged traffic, and the voice VLAN is really that tagged traffic here. But if you think of it from a switching perspective, when you've got that access interface, so there'll be set interfaces GIGI 006 family Ethernet switching interface mode access, it's really then only going to accept untagged traffic. The untagged traffic comes into the interface, and the switch then tags all of those frames received with whatever that VLAN identifier actually is. But now on this GIGI 006, we are receiving both untagged and tagged traffic. And this is because this VoIP phone here usually gives connectivity to some terminal, a PC, a laptop, or whatever it may be. And that could also be supplying power over Ethernet here, and maybe you've got power over Ethernet here as well. That's the topic we just done. But the voice traffic is coming up to the switch tagged, so it's already coming with its own VLAN identifier, whereas the data traffic here, it's coming up to the switch untagged. And that's where you could see we've got tagged and untagged traffic. Now, as these frames come into the switch, we need to define the switch to accept this data traffic and assign it to a particular VLAN, like VLAN 10, just for example. And maybe for this tagged traffic already, maybe that will go into VLAN 20. Obviously VLAN 20 being what's already configured on the VoIP phone itself. And I'm going to do it in a different color now because there's a lot of red here. So when you've got data traffic which is coming in untagged and voice traffic which is coming in tagged, what you can also do with the voice configuration or VoIP configuration is you could define the class of service I'm going to do this for a later video. There's a lot of mechanisms for class of service. There's a lot of moving parts. It's certainly going to be quite a few videos. But for voice traffic, you might want this to go into a a class of service queue or forwarding class that is expedited forwarding. For example, with a particular drop profile, with a particular transmission rate, with particular congestion management control, all these mechanisms within class of service. But maybe that data traffic, the untagged traffic, is going to go into a class of service which might be assured forwarding, or maybe even best effort, because data traffic usually runs something like TCP, and you're always going to get those kind of TCP RAN transmissions in the event of excessive latency or even packet loss. So class of service comes in really handy here. We're not going to be defining that in this video, but voice in the configuration, you can define when we receive voice traffic, when we receive data traffic, I want you to go to this particular queue. I want you to go to this particular forwarding class to have this kind of preferential treatment given to you. And these information, the voice VLAN, so I said that was VLAN 20 for the VLAN, for the voice VLAN, and the class of services can all be communicated via LLDP-MED. That's why I've done LLDP-MED to begin with, because not only does it discover who's connected to who and what their capabilities, it can say, I need this class, I need this power over Ethernet demand, and it can even define via those TLVs what is the VLAN associated to that voice traffic and what is the class of service that I expect from a VoIP perspective. But voice VLAN is basically separating that tagged voice traffic from the untagged data traffic. And this is the configuration. I will do this on the Junos, but I will not be able to do any show commands because I don't have a VoIP phone here with me in my home office, and obviously it's a virtual environment on my EVE-NG. But for that GIGI006 interface, you can see we've got the interface GIGI006, and we define it to be an access interface to accept members data, that VLAN data. You can actually see down here under show VLANs, the data tag has been given VLAN ID of 10. So this would then go through into VLAN 10 when that traffic has been received. But you can also, and just ignore the GIGI0012, that's for the uplink, but you can then see the show switch options. Under the switch options, you define that VoIP profile. You need to say what is the interface I'm going to be receiving that VoIP traffic, so that's the GIGI006 interface, and what is the VLAN I want to be associated to this VoIP traffic. So that would be the voice here, VLAN 20, and you can see it's even defining VLAN voice here. And then, as I said, you can even define the forwarding class, expedited forwarding, or as I said, EF, and that's assuming you've got class of service, all the mechanisms set up. But to define it, as you can see, so simple. So here I am back on the lab, and let's go back into the VEX switch. Now let's define that VoIP and data traffic. And there you go, I've just brought up a few illustrations just to keep track of what I'm actually doing. First, it's define these VLANs. So what I'm going to do is set VLANs. I'm going to call this data VLAN ID of 20, and I can even give this a layer 3 interface of, say, IRB. Well, actually it's 10, isn't it? VLAN ID 10, layer 3 interface of IRB.10 if you want to have the gateway on this VEX switch for into VLAN routing maybe. And let's do the same. Let's do set VLANs voice, VLAN ID 20, layer 3 interface again. Let's make the gateway on this EX switch. And there we go. Let's do show VLANs. That's the configuration there. And let's do show interfaces GIGI001, which is pointed towards the VoIP phone. Nothing really configured there. So let's change that. Just do GIGI001, unit 0, family Ethernet switching interface mode, access, and VLAN members. Don't forget this needs to be the data VLAN, because the access interface only works with untagged traffic. So we define data here, and now we go into edit switch options. Let's do show, and nothing there, but if I do set question mark right at the bottom, nearly at the bottom, we've got the VoIP configuration. So let's do VoIP hit question mark, and I can now define where's the interface that I want to receive tagged traffic on, VoIP traffic on. So that is the GigE 001 interface. Hit question mark. I can now define what is that VLAN that I will receive this tagged traffic. That is VLAN ID 20. And I can even define the forwarding class in assured forwarding, best effort, expedited forwarding, or network control. These are the defaults. Obviously, you can define your own forwarding classes. That's for a later video. But let's keep it as per the illustration. Expedited forwarding is to show done. That is how to configure VoIP on Junos devices. So in summary, I've configured my VoIP configuration to accept tagged traffic with a VLAN ID of 20 on the GigE 001 interface, and when I receive tagged traffic with this VLAN from the VoIP phone, Junos will forward this traffic to this queue, this forwarding class of expedited forwarding. And I also configured the VLANs, data, VLAN ID 10, voice VLAN ID 20, each with their own layer 3 interface, which I haven't done it, but then they could have their own IP address, and that gateway would then be on this VEX switch. Simple, quick, easy. So there we go, everybody. That is the end of this video. That is the end of how to configure LLDP, LLDP-MED, PoE and voice VLAN on Juniper switches. As always, I hope you found that useful. Hope you found that informative. Quite a bit of information, more so on the theory side. Really, from a configuration perspective, it's incredibly easy for all of those topics, areas, protocols to actually configure. If you liked this video, please give me a thumbs up. It's the best way to support my channel. Any questions or comments, let me know down in the comments box. I love hearing from you all. Other than that, thanks for watching and goodbye.